Hello, everyone. Good evening, dear authors and invited guests. I welcome you all to the technical session 7E. Myself, Anjali, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress on Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th 21st February 2023, and the virtual event will be held through Zoom today and tomorrow, that is 22nd and 23rd February 2023. I hope you'll enjoy the knowledgeable and interactive session through the day. In this session, we have 4 presentations and each presentation will be given 12 minutes for their presentation and then 3 minutes for the question and answer round. On 10 minutes, I'll be raising a gentle reminder for you to conclude the meeting, to conclude your presentation. There is another request to all the participants that you please stay connected with us the closing remarks. And if you have any query or any update, then you can get started. I would like to introduce you all to our session chair. We have our session chair, Dr. Rainer Alfred, here with us. Dr. Rainer Alfred is an associate professor of computer science at the Faculty of Computing and Informatics, University Malaysia Sabah in Malaysia. He holds a PhD degree in computer science from York University, UK. He has authored and co-authored more than 150 journals, books, chapters, and conference papers, editorials. Ren is currently a member of IEEE, a certified software tester from the International Software Testing Qualifications Board, ISTQB, and also a certified IBM DB2 academic associate. We welcome you, sir. Thank you so much for being here with us.
Thank you.
Also, we would like to welcome our second session chair, Dr. Vivek Tiwari. Dr. Vivek Tiwari is an assistant professor of computer science and engineering at International Institute of include data mining, warehousing, pattern mining, warehousing, data analysis, pattern and presentation along with machine learning. We welcome you so much for being here.
Thank you. Thank you. I hope I am audible.
So you're
Thank you.
We'll now move to presentations then. Our our very first presenter on the respective of services. Dear presenter, you may please start your presentation.
So, is my slide visible there?
Yes.
Hello?
Yes.
Yes. Thank you, sir. So, hi, I'm Dr. Sanjay Hanji. I'm working as professor for Keli Technological University, Belagavi, Karnataka, India. So actually, I'm not a computer science grad. I'm a management fellow. But I have a lot of interest in digital transformations in business. So my research topic is adoption of artificial intelligence chatbots in travel and tourism services. So main motivation for this research is basically travel and tourism services are booming in India, and so is the digital transformations in this particular business. And I was keen to know how these AI chatbots, the chatbots are everywhere now in banking, in finance, in retail, and tourism is not an exception. So AI chatbots are there as well. So how is the adoption rate? How much consumers are adopting these technologies for their day-to-day travel and tourism purposes? So that was the main motivation of this study. Yeah, tourism industry is undergoing a significant change due to novel technologies like robotic and artificial intelligence and chatbots. A number of tourism companies, including Expedia, Snap Travel, Mezi, Hypna, are currently using chatbots to conduct their operations. Now, worldwide, if you see, the usage of AI chatbots in airports is expected to grow at 42%. And in tourism sector, a chatbot is used to plan a trip, book a ticket, provide online customer support, make recommendations and suggestions to its customers about their trip. So it gives a lot of such services, but in spite of having a lot of research interest in studying of adoption of technologies in various fields, travel and tourism have received less attention, and research on technology adoption in travel and tourism is still in its infancy. And studies that focus on exploring how tourism is changing due to technological advancements such as AI and robotics are still scarce. Especially when it comes to AI chatbots adoption in travel and tourism, there are very limited studies. Now, need for the study is, in order to have technology-mediated interactions in tourism, there is an urgent need which exists for research in AI chatbot acceptance and adoption. And AI chatbot adoption is another factor, one factor which could potentially affect the profitability of travel and tourism companies. As we have seen, even in banking, I have mentioned in the literature review that banking operations have, tremendous. SBI Bank, like because of its chatbots, their profitability has increased, and that is evident in many companies. And knowing factors responsible for successful adoption of technology would also help software designers and developers in building the right kind of technology which can be easily accepted and adopted in the markets. Now, considering this gap, our research objective was to examine the factors that impact consumer adoption of AI chatbots in travel and tourism sector by extending UT82 model. Now, what is UT82 model? UT82 is a model which actually helps people to understand how is the adoption rate of any new technology. Now, this is the model. So wherein we are checking how awareness of the service impacts performance expectancy of the customers of any technology and effort expectancy, and how these in turn affect the behavioral intention to use any technology. Now, this technology, what we are seeing is AI chatbots. Now, similarly, how social influence, facilitating conditions, hedonic motivation, and habit influences behavioral intention to use AI chatbots, and so as trust and personal innovativeness. So actually, if you see UT82 model, the performance expectancy, effort expectancy, social influence, facilitating conditions, hedonic motivation, and habit directly influences. Now, additional variables, what we have taken in through our literature is trust, personal innovativeness, and awareness of service, which are majorly impacting behavioral intention in other fields. So we wanted to see whether this impacts here as well. Now, research design was, we had used quantitative cross-sectional design, and data collection was a well-structured questionnaire through Google Forms, and sample units were tourists in Indian subcontinent who booked and arranged tours and travel plans on their own. The sampling technique was simple random sampling, and sample size was 266 respondents. Now, when we look at after the collection of the data, we coded the data and checked the reliability and validity of the data, like whether data what we have collected is valid. Now, based on the factor loadings, we can see they are well above the range, and average variance extracted, composite reliability, and Cronbach alpha, as well as the discriminant validity, points out that the data is good for the further analysis. And coming to it's a very simple research. Coming to the direct relationship, what we have studied here. Now we can see here that performance expectancy is performance expectancy is how much customers believe that performance of AI chatbots is good. That it is really day-to-day travel planning or maybe booking the tickets. How is the performance? So this has an impact on behavioral intention to use. That is supported. This hypothesis is supported. Whereas H2, effort expectancy, how much effort they have to put to learn this technology and use it. Is it easy to use or is it difficult to use? Here it says that it is easy to use, and that's why many people are using it. And social influence, friends and family influence has no impact on intention to use. Facilitating conditions like internet technology and the laptops, whatever they have, that does not influence behavioral intention. Hedonic motivation, however, the joy and fun of using this technology is really impacting their intention to use. That means that the software engineers or developers can make it an interesting app. If the app is not interesting, or the the chatbot, if it is not interesting, it is not speaking up to their mark, if that is not understood, then probably usage will be coming down. The habits, yes, any software which is there, it should habituate the customer. If it is not habituating the customer, people will feel bored and they might stop using it. Whereas trust doesn't have any impact, whereas in other researches we have seen that trust plays a very important role, where here it is not having that role. Perceived innovativeness, that personal innovativeness, the person, if he's more innovative to try out new technologies, yes, that has an impact on behavioral intention to use the chatbots. Yes, awareness of the service through performance expectancy and effort expectancy has an impact, but on these two, and also it has an indirect impact on the behavioral intention as well through these factors. So these are the main results. And main thing is we have advocated to the travel companies as well as the software coders, or based on this, like how they can make the technology more interesting for the customers, because at the end, whatever technology is developed has to be used and adopted by the customers. If it is not, the entire effort is going haywards. Now, these are the implications. Now, in recent years, then a good thing is instant messaging arenas like Facebook Messenger, Skype, Snapchat, WhatsApp have experienced substantial increase in communication, and this may have implications for travel companies. And it would be particularly beneficial for organizations in this segment of tourism to maximize use of chatbots and chat robots in order to improve their existing services, because people are habituated to WhatsApp and this thing. Even WhatsApp has come up with its own chatbots. People are adjusting to that as well. This will reduce dependence on hiring more customer service agents, costs, and bring efficiency in their businesses and increase their profits. And some implications for AI chatbot developers: they can focus on improving chatbots performance-wise, because as we have seen in this research, performance plays an important role. Their ease of using makes it more fun and entertaining, that is hedonic wise. So that will have an adoption greater, and clients will also be happy if their customers are happy. They need to develop bots which can habituate customers to use them again and again, when need arises. Otherwise, if they're not getting habituated, if they're not liking it, they'll again go back to the customer services. Again, the costs of keeping the customer service agents will have to be maintained. So less dependency on customer service agents and more if they switch to AI chatbots, if it is more appealing to the customers, then nothing like it. Lastly, communicating and recommending customers to use chatbots for their travel purposes is utmost important in promoting their usage behavior. Conclusion. So our investigation found that performance expectancy, effort expectancy, habit, personal innovativeness of a person, and awareness of the chatbots. Yes, as we have seen that many customers are still not aware, especially in India. If you see, the awareness isn't there. Many customers don't know about the chatbot services. I think companies should look forward to promote their chatbots so that less dependency is there on the customer service, this thing. And these have an impact on behavioral intention, all these factors in tourism services. And hedonic motivation, as we have seen, negatively influenced the intention of AI chatbots. And awareness of the services indirectly influence the intention to use the chatbots. Okay, thank you. So this is
Okay,
all.
thank you, Dr. Sanjay.
Thank you, sir. Thank you.
I have two issues here, two questions.
Yes.
The first one is the model that you shown here. Is that the standard one, or that is your main contribution?
It's a standard one, sir. UT82 model is a standard one. It was developed by Venkatesh 2003, and it was remodified by Venkatesh 2013. It was remodified. Actually, this model was derived out of theory of planned behavior model and by Eisen and technology adoption model. And I have added a few more parameters like trust and personal innovativeness and awareness of service we have added, sir. Otherwise, everything is standard there.
Okay. So the respondent, do you have the demography of the respondent? What range of age? What are their occupation?
Yeah. Actually, I have not put it in the presentation right now. It's there in the paper. So,
okay.
Yeah. So basically, as I remember, like majority of the, we have done a quota sampling as well. Apart from random sampling, we have seen to it that equal amount of respondents, like we have chosen 18 to 25 age and 25 to 35 age, 35 to 45 and 45 and above. So all have been given equal priorities. Almost the sample size have been diverse in all these things. And job holders, like let's say, I think around 65% of the respondents are job holders, and rest 45% people are businessmen and household and retired. So this is what I remember from the paper, because it's there in the system. I just have to pull it out otherwise.
Okay. Okay. Thank you for your presentation, for your contribution. Dr. Vivek, do you have any issue, any question?
Thank you, sir. Thank you. So thanks, Dr. Sanjay, for sharing your research work with the presenters and other authors who are discussing with them. So I have a technical question. I request you to please go to the table 3 where you have represented some results and values. So
Yeah.
I think it is the next slide, table 3. So
yes, sir.
Yeah, I will talk about bit. I think next one. Yeah. I will talk about the bit technical side.
Yes.
First, what I observed, the sample size is limited. So its suggestion, like when we go for the statistical analysis and we conclude our results, it should be supported by the enough variety of samples. First thing, and the sample size we have taken, I think it is a limited. We can limited, just make it more.
Yes, sir.
Second, when the sample size is limited, when the sample size is limited, so what the t value or p value we calculated, it may be biased and significant test may be misleading. So so that side we have to check it. And the last observation is that in the table, that bottom side, like a caption, some values are given like p is less than or equal to 0.001 and 0.01 like that. It's correctly written. I think the last thing is wrongly mentioned. P value should be greater than equal to 0.05. It is written P value is less than equal to 0.05. So I think you have to please relook it. It is wrongly mentioned. If P value is greater than 0.05, then the hypothesis should not be supported like that.
Yes, sir. Basically, I have not written the null hypothesis, sir. As you rightly mentioned, if it is greater than 0.05, then null hypothesis. But here I have written all alternatives, sir. H1, all alternative hypotheses only have written. So I have mentioned it reversely. Like if it is less than, then alternative I am accepting.
Okay, we have to follow what are the standard
Yes, sir. Yes, sir.
meaning of terminology. Otherwise, everything is good. Thank you for my side. My best
Okay,
wishes
sir.
with you. Thank you.
Okay, sir. Thank you, sir. Thank you very much.
Thank you so much. Now we will move on to our next presenter. I would like to invite our next presenter, Fitria M. Sood, to please present their paper on the paper titled Digital Resilience in the Millennial Generation According to the Islamic Paradigm in Southeast Asia. Dear presenter, please present your paper.
Good evening, ladies and gentlemen. First of all, in 18th session of International Congress on Information and Communication Technology, ICICT, allow me to thanks for opportunities that has given to us to present the article with the title Digital Resilience in the Millennial Generation According to the Islamic Paradigm in Southeast Asia. And the second time, let me introduce the presenter and the author team. The speaker today, I am Dr. Fitria M. Sood from University of Muhammadiyah, Yogyakarta, Indonesia, and Dr. Kana Safrina Razi from Alma-Ata University, Indonesia. And the author team is Dr. Faisal bin Hussein Ismail from University Tun Hussein On, Malaysia. Now we're going to move on the main presentation. The agenda, the first is introduction, and then theoretical framework, method, result, and discussion, and the last one is conclusion. Introduction. COVID-19 has required students to interact more intensely with digital due to distance learning. This condition has formed a new habit in adolescents, especially millennial adolescents, in interacting with online media. They face risks, negative effects, dangerous, but also great opportunities with digital activities. And primary goals of the result. Primary goals. How the resilient and self-control skill is choosing the benefit or harm of digital activities are important to know. This study aims to find the resilience of millennial teenagers in digital activities that are included from the Islamic dimension by using resilient digital attributes. And then about theoretical framework. Digital resilience is a dynamic personality asset that grows from digital activation through engaging with appropriate opportunities and challenges online, rather than through avoidance and safety behavior. And then digital resilience is the ability to self-regulate internet and media use and avoid potentially harmful or inappropriate content. And digital resilience have 4 elements. They are know, understand, learn, and recover. And then the methods of the result. This result is a qualitative result with the case study approach. Data collection from a case study result was carried out by direct interview and observation to do research site. However, the collection of data in this qualitative study was supplemented by the dimension of online questionnaire to supplement the interview data. This is due to pandemic conditions that limit the space for researchers to move. The focus of the research is the students in Indonesia and Malaysia. Analysis data was carried out starting by deductively making initial reposition from existing conceptual data, then inductively research, collect data, process, draw, and conclusion. And the research sites due in the Malaysia and Indonesia. In Malaysia, due in ICICT University, Malaysia Terengganu, Terengganu. Yeah, I'm sorry, Terengganu. And then University Tun Hussein on Malaysia at Johor, Malaysia. And then University Science Malaysia, Pulau Penang. And then University Utara Malaysia, Kedah, Malaysia. University Malaya, Selangor. And the last is University Malaysia, Kelantan. And in Indonesia, doing 4 university. The first is Muhammadiyah University in Yogyakarta, and then Alma Ata University, and then Muhammadiyah University of Surakarta. And the next is in Raden Masaid State University in Surakarta, Indonesia. And about result and discussion, the next question will be delivered by Dr. Kana Safina Rozi. The time is yours, Dr. Kana.
Thank you. I will explain the result and discussion. This research has been carried on Indonesia and Malaysia, like my friend said. This is using in-depth interview. The respondent is teenagers who are doing online activities. Interviews focus on finding 4 elements of digital resilience in the Islamic paradigm. The student was found that digital activity has an impact on the learning process and the effort made by Muslim students both in Indonesia and Malaysia. They are to get closer to the religion, but the methods taken are different, so that the resilience of student in facing the influence of digital activity is closely related to their religious behavior. By worshiping and remembering God, they can withdraw from attachment and addiction to doing useless digital activities or negative digital activities. Digital resilience elements are understanding. From the research, we found that they understand the positive role of the internet and are better able to navigate the online environment, so they have better resilience. And then they are also knowing what to do to seek help. Know what to do to seek help from potential harmful or inappropriate content that will damage their individual psychology. And they are found that learning from experience, that means that learning knowledge and skill, including learning how to recognize and manage risks, and learning from difficult experience, again from digital experience. And then they are having the right support for recovery, which is a description of adaptation process. So like we said that before, from the result that we got, that we found three factors that developing a resilient attitude. The first one is adaptability. Adaptability has been proven over time during the pandemic. As a Muslim, what you have to do is to be adaptive and not easily complain about situation and condition.
Author, sorry for interfering. It's 10 minutes already over, so please, within a 2 minutes, try to conclude it.
Oh, okay.
We have limited time. We have a limited time. Yeah.
Okay. And then we get their religiosity, and then social environment. So we have conclude that wait. This is Islamic digital resilience. We have adaptability, not easily complete, and believe that God is all saying. God loves and forgives His servant. Nggak kelihatan. So the conclusion is overall respondents were able to refrain from negative things resulting from digital activity. and not only from their education and knowledge of the content of this digital activity, but rather the ability to refrain based on deeply religious understanding, where most of the respondents were Muslim. They realize that the guitar activity they do, even if no one is watching, they realize that the supervision of their God is more than the supervision of parents and the surrounding environment. It is because of this feeling of being watched that they are able to control themselves from application that contain negative effect. Based on this experience, it can be concluded that the respondent have Islamic resilience. This is where digital activities based on religion are not just a checklist or a switch, but that is where the values lies. Thank you for your attention, and it's be back to the moderator.
Okay, thank you, Dr. Fitria and Dr. Kana. I saw that you get respondent from a few universities, 5 from Malaysia and 4 from Indonesia. So, so the population is quite big. So, how many respondents do you have from the population of the university student?
27. Only 27 because they did interview.
How many respondents?
27, Prof.
Oh, 27. So if you look at the population of the student at the university and you only interview 27, the margin of error, the estimated margin of error is quite big. Looking at your samples, is there any way you can automate the interview so that you can capture more respondents? Because in the future, I think it's good to look at the statistic validity of your samples in order to support your conclusion. So that's the only issue I can see here. And also, since you are looking at the Islamic, the religious one, so you are looking at interviewing Muslim student only.
Yes, thank you very much for your suggestion, Prof. I will
Okay.
do for the next research. Inshallah.
Okay.
Thank you, sir. Thank you. So I will end up with a simple suggestion. So always try to discuss the scientific or logical background by which you come up with your conclusion. So the way you have collected the data, what was the features column, and the conclusion you are coming with the data. So how the mapping we can look in between what the scientific method or logical reasoning you have adopted to come up with the conclusion. So that was the missing during the presentation. So that is the one thing we can improve. Thank you.
Thank you, sir.
Thank you.
Yeah. Thank you.
Thank you so much, Fitria. Now we'll move on to our next presenter. I would like to request our next presenter, Luis Enrique Mujica, to please present their presentation on FPGA embedded signal conditioning system based on fuzzy logic for temperature measurement. Dear presenter, please present your presentation.
Yes. Good afternoon. Oh. Good afternoon. My name is Luis Enrique Chinea Mujica. I am a mechatronic engineer, and I am studying in a Master in Science in Electronics Engineering in the National Technology Institute of Mexico in Celaya. The title of my work is FPGA Embedded Signal Conditioning System based on fuzzy logic for temperature measurement. The collaborator of this work belonged to the National Technology Institute of Mexico in Celaya and the National Polytechnic Institute in Mexico City. The topic of this work are a brief introduction, materials and methods, results, and conclusions. Most of the measured physical variables in the industry are analog signals. Such measurements require signal conditioning due to environmental noise corruption. Some characteristics of conventional signal conditioning system are they must be powered from an external voltage source from 8 to 30 volts. They demand from 30 milliamperes up to 100 milliamperes with no load. The dimensions are particular to each board. Their weight is from 20 grams to more than 100 grams. The price is in the range of $240 to $600. As mentioned, as conventional data acquisition systems require physical space, weight, power consumption, and cost. These features are a problem for applications such as aerospace systems, submarines, autonomous ground vehicles, medical devices, portable systems, among others. The figure shows the general block diagram of a data acquisition system. This diagram starts with a physical system variable and a transduction block. Then, the analog signal conditioning includes several stages, like amplification, filtering, linearization, and theorem span. Then, the signal is converted to digital, and finally, the data is processed. The present work proposes a signal conditioning system based on fuzzy logic, implemented on an FPGA. The main contribution is that it allows excluding the use of external hardware in the signal conditioning process. But why fuzzy logic? Well, fuzzy logic systems are less susceptible to parameter tunings. Also, it's easy to operate as they use only sensor data, being an alternative to the Kalman filter and its variation. And why an FPGA? Well, the implementation in an FPGA improves the speed of response due to its parallel processing concerning in its operation in software. One of the significant advantages of FPGA implementation is portability, which means that the same hardware description can be implemented in different FPGA brands. It is resulting in more application options. The materials we use in this experiment are a temperature sensor LM35 with a conversion factor of 10 millivolts per Celsius degrees, an analog to digital converter PMOD 81 with 12 bits, and a platform Nexus 3 by Digilink, which includes an Spartan C. In the figure, we present the implemented experiment, which A is the platform Nexus 3, B is the temperature sensor, and C is the analog to converter module. Here, we show a block diagram of the general experiment, which include several stages. First, temperature value is sensed as an analog signal. Then, the analog signal is sampled and converted to digital. The digital signal is scaled, and the analog signal conditioning is performed through a fuzzy logic stage. The temperature value is converted from binary to BCD. The resulted BCD value is transmitted to a personal computer through an asynchronous port RS-232. We use the Takagi-Sugeno-Kan method because the fuzzy system output is defined directly from an obtained set of linear functions. Because of this advantage, the falsification process can be avoided. Two values, C and W, are generated by each rule. C output level can be a constant value or given by a linear combination of input values, where X and Y are the system inputs. Rule weights W are computed by the equation number 2, where F1 and F2 are the membership function of the input 1 and input 2 respectively. The system output FO is the weighted average of all the rule results. The proposed fuzzy system was trained through two sample sets, theoretical and measured values. The fuzzy system was trained using the MATLAB AmphiSedit tool. Once the fuzzy system was trained, the membership function can be plotted by the MATLAB fuzzy tool, from which the coefficient of the three-member function were defined as F1, F2, and F3. The figures show the general block diagram of the implemented fuzzy system. Two finite state machines were designed to control the fuzzy system. The first finite state machine controlled the computing of the membership function weights, whereas the second controlled the final system output process. The polynomials are solved through an accumulate multiplication algorithm. The used data acquisition format was signed fixed point Q12,3, which means 12 bits representing the integer part and 3 bits for the fractional section. The obtained result of the measured temperature values without the signal conditioning system are depicted in the figure on the left. The shown theoretical values are directly obtained from the sensor output signal, and the measured temperature values are computed from the analog to digital converted value. As expected, a significant temperature measurement error is observed due to the absence of a signal conditioning system. The analog signal is highly corrupted by environmental noise, mainly because it has a small value range in millivolts. The third and second regression polynomial give the trend of the measured and theoretical values respectively. Conversely, on the right side, we show the experimental temperature measurement test result, but now we include the implementation on the described fuzzy logic signal conditioning systems. The value trends of the measured and theoretical values are given respectively by the third-order regression polynomials. Here we can see that both regression polynomials look almost identical. Here we show a statistical comparison between the dataset of the theoretical and the measured values. In two cases, the statistics without using any signal conditioning system and the statistics using the described fuzzy logic method. The statistical analysis sample size was 42 elements. A noticeable temperature measurement error reduction is achieved by using the proposed fuzzy system logic signal conditioning. An error reduction relative to the mean value from 305% to 2% was achieved, and the error relative to the variance values from 1,851% to 2.64% was obtained. We must remember that the present work proposes a signal conditioning system based on fuzzy logic and implemented in an FPGA to replace a conventional one. This objective aims to reduce volume, weight, power consumption, and cost derived from conventional data acquisition systems. The following conclusions demonstrate the accomplishment of this objective. The error relative to the mean was reduced from 305% to 2%. The error concerning the variance was reduced from 1,851% to 2.64%. The final error obtained with this method is 0.5 Celsius degrees concerning the value delivered by the temperature sensor. The experimental results demonstrate that an accurate measurement can be made without an external hardware dedicated to signal conditioning. Future work can be directed toward the design and development of portable equipment and aerospace systems. Thank you very much for your attention. Do you have any question?
I have a question, if you allow me. What is the resources required for the FPGA in order to run your software? And also in terms of gates and memory, etc.
Sorry, can you repeat the question?
What resources do you need of the FPGA in terms of memory size, gates, etc., etc.? What FPGA would you recommend for this project?
This project doesn't occupy a large space in memory and very much requirements in an FPGA. I think that any FPGA we can use in this project.
Okay, yeah, thank you. I'll probably find more information about it in the paper. I haven't read it yet. Okay, thank you.
Thank you very much.
Thank you from my side. I appreciate the work you have presented over here. So it is good work, and I think you should continue it. So my best wishes to you. Thank you.
Okay, Luis, Enrique.
Yes. Yes.
The proposed technique, how is it different from the existing one, and how your method is better than the existing one?
The project existing use the fuzzy logic as a control to control the process. We use the fuzzy system to replace the signal conditioning system.
Okay. So how significant is the result compared to the one in the literature? How significant the improvement?
The main contribution of our works is that allows to us to save, to save space, weight, power consumption, and is intended to use in embedded system, submarines, aerospace system.
Okay. Okay. So in your last slide, can you look at the slide? The result. The last one, you said that the error relative to the mean was reduced from 300% to 2%. So very
Exactly.
huge, yeah, very huge differences, and I think very significant. So
yes.
Is that true? No mistake there. 300% reduction.
Yes, that's right.
Okay. So this
The
one.
error,
you get
Yes.
for one time running only, for one time running of the experiment, or few times?
Sorry, can you repeat the question? The connection is badly.
The result that you get is based on one running of the experiment only, one time running only, the experiment, or few times?
No, if, the sample size of the experiment was 42 elements. We take 42 measurements.
Okay, okay.
Yes,
So you can perform the t-test, right?
yes. The huge effort is because of the output signal of the temperature sensor is in the range of millivolts, and is affected by the noise.
I have one more question, if you don't mind, if we have
Yes.
time. Okay, you said you reduced the error by 300% or so, but have you compared the same system with a similar system but using signal conditioning module? Let's say the same sensor you take, now you put it directly to your FPGA with a ADC converter. Can you measure the same sensor through signal conditioning module and see what the differences in error is? Or you have
no, we not try that experiment.
Yeah, the 300% is when you expect that this is huge problem because it's in range of millivolts, and the ADC will have just 3 bits significant data, so you expect that margin of error. But if you use signal conditioning to amplify, filter, etc., I think it's probably for your future work to compare your existing solutions to your solution and see how they compare in terms of error and in terms of other parameters like speed, for example. So yeah, but yeah, you said you haven't done it yet. Okay, thank you.
Yeah. Thank you, Dr. Konstantin. Okay, thank you, Luis.
You're welcome.
Thank you very much. Have a nice day.
Yeah.
Thank you so much, Luis. We will now move on to our next presenter. I would like to request our next presenter, Dr. Konstantin, present their paper on lightweight network architecture for tethered underwater vehicles.
Okay, thank you very much. Let me share the screen. Okay. Right, this is sort of a similar type of presentation. It's about marine engineering. That's the reason I've been interested in the previous presenter. Can you see my screen?
Yes, it's visible.
Okay, so it's the same type of presentation. It's about marine engineering, and it's the same thing, optimization work regarding networking that's running over the submersibles controlled by a cable from the surface. So it's called a remotely operated vehicle. These submersibles, these are non-crewed machines that submerge and provide video stream and other sensory data from the seabed, and they are used for exploring the ocean seabed, also some infrastructures on the seabed, etc., etc. So these are very popular machines because they don't have a crew. It's much safer and they are much cheaper than manned submarines. The system consists of the vehicle itself, called ROV, remotely operated vehicle, remote control console, which is sort of a computer with various controls, knobs and ports, etc., and the cable, which is called tether. These 3 components, they form sort of a network. because all the video stream and sensory data come from the vehicle to the computer on the surface. And on the other way, the computer sends commands to control the vehicle. It controls the thrust, it maneuvers and positions the vehicle on the particular point of the water where the data is required to be taken from. The optimization is required because these systems usually run on well, sort of off-the-shelf standard equipment, and this equipment not always, particularly the high-speed internet devices, they are not always suitable for underwater exploration because of the high number of wire cells. Scroll one more slide. You see, this is a typical commercial off-the-shelf underwater vehicle. You see these connectors, they have various of pins, various number of pins, location, etc. All this is very expensive and very prone to failure because underwater you have a corrosive environment, you have huge pressure, and these connectors fail. So as many connectors, as many pins you have, more prone to failure equipment you have, and also it's very expensive. This panel costs maybe several £1,000, up to £10,000, just the panel with the connectors. So this work is about how to get rid of all this and make it very simple for building and very simple for maintenance. The first thing to do is to see all the players involved in this network. And in our case, this is the remote console on the left. And also, as I said, this is a computer. And to the computer, usually you use standard Ethernet networking of some sort, either fiber or Cat5 cable. The connection between the vehicle, the remote operated vehicle, and the console is just a cable. So this is also a problem because if you'd like to put through this cable a standard network Cat5, there are 6 wires in this cable, so it becomes a really thick cable. So this is also a problem which needs to be resolved. And the console on the surface, the remote control console, should talk to the cameras, should receive the video stream, should control the actuators, the thrusters, and get some data from the temperature sensors, pressure sensors, and other things you want to explore underwater. These all players in the network, they have very different requirements from the network, and it's really hard to put everything in the same net. So the remote console should have a high throughput because of the video stream, the cameras as well. But the thrusters, they don't have that requirement for the throughput. They need to just few bytes per second in order to get the set point for the speed. But on the other hand, the controller should have a low latency so that the vehicle is controlled properly. You don't want to delay when you send a command and wait so that the thrusters run in a few seconds. So you need very low latency of thruster controller, for example. So saying this, we have to choose the right network topology. And for example, the usual bus and usual star, which is common in the network industry, they're not quite suitable for underwater vehicles because, as I said, there are very different players in this network, and you're more like to have a hybrid, and components with similar requirements to be grouped in the same subnet, and the other grouped in the different subnet. When I say subnet, it's not an IP TCP/IP subnet as IP addresses. It's just a different physical subnets. The proposed subnet is a hybrid one, and it groups the high-speed devices like video cameras or sensors like multi-beam echo sonars where they have high throughput requirements in one subnet called high-speed subnet, and one low-speed subnet, which is all the other devices like temperature sensor, pressure sensor, thrusters, etc., etc. So between those subnets, because from the remote control console on the surface to the vehicle, you have just one net. You can't afford to have a tether with various of wires because it will become very thick and expensive. So you obviously get the high subnet through the tether and then split from it a branch to run the low speed subnet devices. And the high-performance subnet is based, in our case, in the home plug technology, which is power line communication modem, where all the Ethernet communications are through just two wire of cable. There is no Cat5 cable whatsoever over the cable that carries the power to the vehicle. You also transmit the information over the PLC, power line communication. This is how the power line communication modem look like. These are obviously consumer-based modems, but you can get.
Dr. Konstantin,
Yeah.
I think the slide is not moving. It's stay on page 30. Oh.
That's
Okay. Yeah.
so okay.
Now we are at page 10.
Okay. Right.
Okay.
I don't know why it's getting like that. Are they moving now?
Yeah. Now moving. Page 11 now.
Okay.
Okay, proceed.
What slide do you see now?
11.
11.
Slide
No,
11.
it's wrong. It's wrong.
But,
I'm not sure why.
okay, now 10. Okay.
10. Okay.
Yeah. Okay.
So for the low-speed network, you have various options because it's a local net, very low-speed local net. We have RS-232, RS-485, ACI campus, etc., etc. What we decided to use is more popular these days, LIN, which is local interconnected network, which is used for cars. Your car is usually using LIN for getting data from the sensors and switches and operate the lights, etc. And it requires only one wire, which is very attractive because underwater, as I said, all the pins count and you don't want to have a lot of pins. So one wire network, one wire bus is really attractive. Let me change the slides. Which slides do you see now?
Slide 10.
Okay, so now.
Okay, 12. Yeah.
Okay, so this is how Linbus works. It's just one wire, common collector or common brain architecture when everything is connected to a single wire. And there is a master endpoint and slave endpoints, and the master controls the whole line. When the master sends the command to the slaves receive the command, executes it, and then some slaves can reply back. So this is so slide 13. The protocol we decided to implement, it's based on the LIN physical layer, but it's not the LIN logical layer because it's, as I said, it's targeted the car industry where you don't need really a lot of data. In our case, we somehow need a lot of data to be transmitted, so we modified the logical protocol. And also in the LIN protocol, there is no synchronizing messaging between the master and the slave. The LIN actually expects something and replies back, and there is no guarantee that it will reply at the same time in a timely manner. So our protocol takes care of this thing, and it's based on time slots controlled by the master. The master broadcasts a message, which is the message here blue. And the message contains the data for all the slaves that to be executed. For example, if you have, as in our case, 3 devices, let's say 3 thrusters, the message contains the data for all the thrusters, in this case 3 bytes per thruster. And then sending this to the slaves, all the slaves receive the message simultaneously, and they parse the message, they take their part, and they execute it in sync. So when the master sends a message, all slave devices execute the command synchronously, which is very, very, very important for the underwater movement and maneuvering. On the message as well, you have the ID, which is the first byte, and this byte requests the slave, which is byte putting this ID field to respond, and the slave, which is mentioned in the message, responds with a reply, which is down there. It could be arbitrary length of bytes. So you can have, for example, from the thruster, the speed, the power consumption, and all this stuff. So this LUN protocol, which stands for Light Underwater Network Protocol, takes care of the synchronization of the slave devices, and it's actually capable of running to one wired bus, which is very attractive for the underwater vehicles. So this is actually how it looks from the OZ 7-layer OZ network point of view. You have a vessel on the top left where you have remote control console, which is a computer on all the 7 layers of the OZ model. Then you have the vehicle on the bottom. You have an Ethernet hub that runs on one side, splitting through the LAN-to-LAN bridge, the low performance network, which I mentioned, which run that protocol just explained, and the normal LAN or Ethernet part, which is all the cameras and high-speed requirement modules that run on there. In architecture has been used in the commercial vehicle. In the at the Technical University in Varna, there were projects funded by European Commission, and 2 vehicles being produced using that technology. And these vehicles are in use for Black Sea exploration in Varna, Bulgaria at the moment. And the last slide. There's some real picture using the technology just explained from the Black Sea sea bottom. And more or less that was it. Thank you very much, and if you have any questions.
Yeah, thank you, Dr. Konstantin. Very interesting paper. Why do you call it lightweight?
Because because this low-speed subnet is really lightweight. It requires only one wire to be transmitted, apart from the power, obviously. And if you remember the second slide with, I'm not sure if you've seen the slide, by the way, I'll share it again. Maybe you missed it. So this is the slide. This is what a current remotely operated vehicle back is. See how many pins and how many connectors. This is just ridiculous. And in our case, we have just one connector coming out of the vehicle with just 3 pins carrying power and this lightweight network. And this is all that goes out of the vehicle, and all the thrusters and the sensors, they're underwater, they're taking power from the connector and respond to the network command from this one pin. That's why I call it lightweight.
Okay.
It's really, really light.
So the machine is already working.
Yes.
The one
Yeah.
that you show. Okay.
Yeah, exactly. And I can show off a bit. If you've seen, there's a program on National Geographic Channel called Lost Cities with Albert Lind. Did that show a guy, it's one-legged guy, a very, very clever one, goes from place to place and explores the local lost civilizations. So he came to Bulgaria 2 years ago, and we made a documentary with him,
Okay.
exploring the lost civilization on the Black Sea bottom, and we used that vehicle to do the research.
Okay.
So it's a documentary, by the way. You can see it in the in action. Yeah.
I've been to Bulgaria, to Sofia and Varna, and I went to Black Sea, but I can't see why they call it Black Sea. It's a
it's a very nice one.
Yeah.
Yeah, but
Okay.
ancient Greeks didn't think so.
Yeah.
For them, it was really, really hard. Coming from the Mediterranean and to the Black Sea, it was hard.
Okay, thank you for your talk, Dr. Konstantin.
Yeah, you're very welcome.
Do we have any questions, Dr. Vivek?
Thank you. It was really a great presentation, and the question asked by the session chair was really interesting, and the same question I thought of asking. So there's no question from my side, and I really like that presentation. Thank you.
Thank you very much. Thank you.
Thank you so much, Dr. Konstantin. Now, since we are done with all our presentations, we would like to move on to our closing remarks. I would sincerely like to thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of the conference. We'll be happy to see you in the 9th version in 2024 as well. All the presenters, they'll be getting a digital certificate through email within the 2 working days. And further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. I really request all of you to kindly cooperate with the team of ICICT 2022. I would also like to thank our session chairs for this session, for chairing the session. Here's a token of appreciation to the chair on behalf of Team ICICT 2023 and Global Knowledge Research Foundation and Powers. Thank you so much, sir. We are thankful for your valuable presence.
You're most welcome.
I would also like to request to all of you to please turn on your cameras for a quick snapshot for this virtual conference. If everyone can please turn on the cameras. Thank you so much, everyone. Please take care and stay safe. Thank you so much.
Thank you.
See you around.
Thank you.
Bye.
Thank you very much.
Thank you.
Bye.
Bye.
Thank you.
Bye.